Good morning, Year 11. So today we're going to go through some bearings work, Venn diagrams, a little bit of algebra, Pythagoras and similar shapes. I'm going to zoom through this as quickly as I can. So with bearings, you want to get your 360-degree protractor in your exam. That will be on your exam desk and use that. However, at home you possibly don't have one of those. So today you're going to have to use your 180-degree protractor. So I'll run through both of those. So first question, find the bearing of B from A. That means you're at A and you want to get to B. First thing you need to do is to draw a line between A and B. You then need to construct a north line. So that is a line that goes directly upwards at A. And you can also draw one at B just to make your diagram look a little bit neater. There we go. So construct your north lines. From A, we want to measure the bearing of A. That takes you to B. Remember three things with bearings: north line, clockwise, three-figure bearings. So that means we want to measure from A. So you're going to put your 180-degree protractor, put the centre on A, and have the zero line at north, up here. And then you're going to want to find the outside numbers. So all the way around here, we've got 110, so it's just looking like it's a little bit past 110. Just going to line it up as accurately as I can. So I think just slightly past 110, so I'm going to go for 111. Yours may be 112, maybe 130, maybe a bit less. It all depends on the way you've drawn your line between A and B, and also your north line. They may be slightly different to me, so you may get a slightly different number there. In your exam, you're just going to pop on your 360-degree protractor onto A, and again, line it all up with 0 at the top, read your outside numbers, find where B is, and here we go, just past 110 for me. You may get yours slightly different. For question 2, find the bearing of A from B. This time we are at B. We want to get back to A. Now this is where the 360-degree protractor really is useful. Draw your north line at B, and I'm going to draw a north line at A as well. This time you're at B, so imagine you're facing north. You want to get to A. Now you must always go clockwise, so it's this angle here you need to find. Now in your exam, you're going to use your 360-degree protractor, a bit like this. Pop the centre on B, 0 follows your north line up, and then it's going to be your outside numbers. So we're looking at this number here, which looks a tiny bit before 320, so perhaps about 319. Now yours again will be slightly different to me because we've all drawn our lines and north lines slightly differently. And that's fine. Now, if you've got the 180-degree protractor, the easiest way is to measure the acute angle and take that away from 360 to get this one. That's the easiest way to do these. Now, because we're going in the opposite direction, we're going to have to use those inside numbers. So we're going to have to start 0 here and go in this direction. So 10, 20, 30, 40... Now, let's have a little look. 40. That actually looks about 42 to me, which doesn't quite line up, but again, it's just the way it's been drawn. So if I do 360 minus 42, I'm getting about 318. They should add up to 360, but it's just the way we're measuring it. Just slightly off there. So if you have the 180-degree protractor, measure the acute angle, take it away from 360. But in your exam, it's far easier to have your 360-degree protractor, outside numbers, and line it up. So yeah, 300 and... yeah, that probably is about 318 actually. So let's just change that one to 318. And this one here looked like it was 42 degrees. So then they do add up to 360. So accurately, measure it as accurate as you can. So we've got to draw this one. A is 9 meters from B on a bearing of 40 degrees. Now, I've made a little mistake here, haven't I? I should have put 0 for 0 on there. First thing we need to do is work out our scale factor. So 9 meters. So we want to go from meters back into centimeters. So we're going to divide by the scale factor. So 9 divided by 3. That means we're drawing a 3 centimeter line. So here we are at B, and we want to draw where A is. Now it's on a 40-degree angle. So we are going to have to draw our north line at B. So let's draw a line straight up. And then we want to measure 40 degrees. So in your exam, use your 360-degree protractor, 0 at the top, and measure 40 degrees. For today, though, we're going to have to use our 180-degree protractor. So pop that on B. Outside numbers, you're going to find 40, 10, 20, 30. Here is 40, and mark off 40. You then need to get your ruler and draw a 4 centimeter line. Nope. A 3 centimeter line in the direction of our marker. So we're going to put that at the center of B and draw a 4 centimeters, sorry, a 3 centimeter line from B. There we go. When you stop there, you can do a little cross, and then we're going to label that as A. The next one we're doing is 2 different locations, and we want to find where A is compared to where C and B are located. So A is on a bearing of 300 degrees from B and 110 degrees from C. Find A. Now, because you're in your exam, you're going to use your 360-degree protractor. You're going to find B and find 300 degrees from B. So you put your protractor on B and you find 300 degrees, which is over here. However, yours is a bit trickier today, isn't it? Because you're going to have your 180-degree protractor. So we're going to have to work out the acute angle. So 360 minus 300, that means we're going to have to do 60 degrees anti-clockwise. So we're going to have to put our protractor on B. And let's draw a north line to help us out. So put a protractor on B, and then you're going to need to find 60 degrees anti-clockwise, which is here. So mark off 60 degrees anti-clockwise. That's 300 degrees clockwise. We don't know how far you're going to travel. Now, in your exam, you should really be doing these in pencil. So I'm going to actually go over to pencil now. So it's in that direction. We don't know how long for. It's 110 degrees from C. So now you're going to get your protractor and pop it on C. And we're going to find 110 degrees. And I think we've got a bit of a problem with this one. I don't think they're going to meet. Let's just draw our little north line. So 110 degrees. Here's 0, and 110 degrees is here. And I don't think they're going to meet in that direction there. Now, ideally what would happen is I would have pre-planned this a bit better, and those two would have crossed each other. So what I'm going to do is to change 300 to 330. So let's just change that to 330. And I'm going to redo that one. Sorry about that, guys. So that's going to get us 360 minus 330 means we're going to now recalculate. So let's redraw 330 degrees. So we're going to move it around this way, and we're going to actually draw an angle of 30 degrees anti-clockwise. And hopefully this time the paths will cross. So we're going to, instead of drawing a 300-degree line, we're going to draw a 330-degree line and go in this direction. In your exam, I promise you it will work. There we go. So that is where A must be. The two lines have to cross to make this question work. Now, I have already done the answers, and I found this happened with your question paper. So if you could change question 6 from 280 degrees to 230 degrees, they will then cross, because I had the same problem where I just found the two numbers and thought they would cross, but they haven't. So just change 280 to 230. The two lines should therefore cross, and you can mark off the point that they cross. Right, on to some Venn diagram work then. So I'm just going to show you a few Venn diagrams that I just quickly sketched now. Here we are. So have a look at these, and I've shaded which ones are. I've done it just quite quickly, to be honest. You can probably look up a neater one on the internet. So A or B. The word, no, not all. Sorry, wrong one. A and B. So this means it could be in A, and it has to be in A and it has to be in B. So A and B. Now I think of that as the N in the word and. So it has to be in A and it has to be in B. This one here is or. So it doesn't really look like an O. But in my head it kind of, I force it to look a bit like an O. A or B. It could be in A, or it could be in B, or it could be in both. This symbol here means not. So it's the opposite of this one here, basically. So this is A and B, but it's not in A and B. So it's the opposite of this one here. So everything apart from the centre. This one is A or B, but not that. So it's the opposite of this. So basically just the outside. And then you've got a couple of different ones here. So this one here says it's not in A, or it could be in B. So basically anything that is not in A, but could be in B. So that's why that little bit there does get included. So not in A, but it could be in B. And this one is, it's A and not B. So it has to be in A, and anything it's not in, that's not in B. So can't be this bit here because that's part of B, but it has to be in A. So these are kind of opposites. So let's have a go at some questions. We need to pop these numbers into the Venn diagram. Square numbers in A, prime numbers in B. Well, your square numbers, 1, which is not a prime number. 2 is a prime number, so that's going to go in B. 3 is neither square, but it is prime, so 3 is going to go in there. 4 is a square number, so that's going to go there. 5 is a prime number. 6 is neither. 7 is a prime number. 8 is neither. And that's all we need. 9 would be a square number, not a prime number. So there we go. Nothing in the middle for these ones. So let's calculate these. So A and B, the middle bit, there's none in there, so we put 0. What's the probability of a number being in A or B? So it could be 1, 2, 3, 4, 5, any of those. 6 out of 8. This means anything that's not in A. Well, anything that's outside of A circle. 1, 2, 3, 4, 5, 6. And then not in B. So anything outside of B circle. 1, 2, 3, 4 out of 8. This one here is A or B, but not that. So anything on the outside, so 1, 2 out of 8. This one is not in A and not in, so it's not in A and B. So not in A and B, well that's going to be all of the numbers because it's everything apart from that. So that's going to be 8 out of 8 or 1. This one is, it's not in A or B. So not in A. So basically anything apart from these two here. So 1, 2, 3, 4, 5, those 6 out of 8. This one is, it's in A and not B. So basically just this part here. So only A. So that means only A. So that would be 2 out of 8. Right, expanding our double brackets then. So we've got x times x, which is x squared. X times minus 4, minus 4x. 3 times x is 3x. 3 times minus 4 is minus 12. That ends up being an x squared. Minus 4x's, add an x gets you minus 1x. And then drop down the minus 12. X times x is x squared. X times minus 6 is minus 6x. Minus 2 times x is minus 2x. Minus 6 times minus 2, that's going to be a plus 12. So we're going to get x squared minus 6 minus 2 is minus 8x, and then add 12. Okay, a little bit of Pythagoras now. Whenever you're asked to calculate the diagonal of a rectangle, think Pythagoras because it has a right angle. If you have the length and the width, you can use Pythagoras. So we're going to do 6 squared plus 2 squared. So that's going to be 36, add 4. So 41. So 40. So 36 add 4, which is 40. And then we're going to square root of 40. So you're going to need your calculator for this one. So it's going to be the square root of 40. 6.32. There we go. Now for your similar shape questions, we've got the height of this small triangle here is 5, and we have this larger triangle around it, and that's the height we want to find. Now these are two similar triangles because they share a right angle and they share this angle here, both of them. Ignore this line here, I made a mistake with that. So you need to have the total base because you need to work out the scale factor, and then you're going to divide that by the smaller base. So the total base, which is 12, and then you're going to divide that by the smaller base, which gets you 4. So that means 3 times 4 gets you the total base. So we say the length scale factor is 4. So you know the small height is 5, times that by your scale factor, which means the height is 20 centimetres. So when you get these questions, it's going to be the big length divided by the small length to get your scale factor. Okay, press pause and then play when you're ready for your answers. Now with these bearings, you can be out by a few degrees. So tick it if you're a couple of degrees either side of mine. So I've got 123 degrees. I've got 315 degrees. It was 54 degrees. Now your answer has to be 054 for 3-figure bearings. 305. This one was a bit annoying because it did go on to the writing, didn't it? So you had to divide 8 by 2 to get 4 centimetres. And then on a bearing of 150 degrees from B. I didn't draw a north line there. Let's draw that in. That looks a bit strange. So that there must have been 150 degrees, and I drew a 4 centimetre line. So A ended up just below the letter A there. We did have to change this one to make it fit, so we changed it to 230 degrees. And just roughly looking at my diagram and your diagram, mine ended up looking a bit like this. Okay, we didn't actually go over these ones, did we? However, these were not drawn to scale. If this is 70 degrees, you can use the fact that this one here is also 70 degrees to work out the bearing of B from A. So you're actually wanting to work out this angle here. Well, these two here are 70. This is a straight line at 180. If you add them together, you get 250 degrees. Let's do the same with this one. Find the bearing of B from A. So this angle here is what we're trying to find. Now we know all of this is 290. So if we extend this line down here, we then have two corresponding angles. If you take 290 and subtract the straight line, that gets you 110. So this must be 110 degrees. Corresponding angles means that must also be 110 degrees. I'll set you some questions on MathsWatch on that. Okay, the answers now. Annoyingly, I decided to draw my Venn diagrams on the other side of the questions, which means they've gone through a little bit. So apologies for that. So for your Venn diagram, you should have got 1 in A, 3, 5, 7 in the middle, and then 2, 4, 6 and 8 on the outside. Your prime numbers being the ones that are odd and prime in the middle. So you've got 3 over 8, 4 over 8, 4 over 8, 5 over 8, 4 over 8, 5 over 8, 7 over 8, and then 1 over 8. Expand in your brackets, x squared plus 8x plus 12. Question 2, x squared plus 3x minus 10. X squared minus x minus 12. X squared minus 4x minus 12. X squared minus 7x, add 12. Let the diagonals 9.49, 12.65, 9.43 and 10.44. Similar shapes, 8 divided by 4 gives you a length scale factor of 2. 3 times 2 is 6. 15 divided by 7, not a very nice one to calculate with. Got you 2.14, times that by 2. I kept my number on my calculator screen and then rounded to 4.29. And this one here, 9 divided by 4 gives you a scale factor of 2.25. Times that by 6 gives you a base of 13.5. Okay, well done for those. I will set you guys some questions on MathsWatch based on those. Thank you very much. Have a good day.